very happy to be here. I have the pleasure of introducing John Cerone and the incredible work that's being done at SHoP Architects. But before I do that, I'm going to talk for 3 minutes about Dassault Systèmes. What is Dassault? Who is Dassault? Who is Dassault Systèmes? What is CATIA? And why should you care? Okay, my name is Jonathan Asher. I'm a part of the CATIA organization. I've been with the company for 10 years. Before that, I was an architect, a computational designer. I worked at Coop Himmelblau in Vienna. And some very interesting projects using CATIA along the way. I was a facade engineer at Zaner. Shout out to the Zaner crew. Before joining the company as the product manager for the CATIA solutions dedicated to the AEC industries. So I'm going to go really quick to give you a brief overview. Who is Dassault Systèmes? We've been around since 1981, a spin-off from Dassault Aviation, a company that makes airplanes. We built the first digital paperless airplane with Boeing back in 1989 and released V5 in a few years later. The first digital building that was built with CATIA was, of course, Frank Gehry and the Guggenheim project. It was a great documentary that was done by the B1M recently, and I encourage you all to check it out. V5 came along in PLM, Product Lifecycle Management. In 2012, we released the 3D Experience platform and CATIA V6. In 2020, we are moving into life sciences and the virtual twin of the human body. And now we're moving into the universe, 3D universes, which John Cerone is going to talk about. What is Dassault Systèmes? Well, we have the 3D Experience platform first and foremost. On that 3D Experience platform, we have a number of brands dedicated to delivering different solutions for different industries. I'm a part of the CATIA organization, 3D Parametric Modeling, but we have brands for construction simulation, project management, and they serve 12 industries: aerospace, automotive, of course, shipbuilding, high tech, consumer goods, and AEC and infrastructure. It's all on the 3D Experience platform, which is the common data environment. Common data environment that is an aggregator of all things necessary for a project. What makes CATIA different? Well, we're smart, modular, generative, and continuous. Smart lends itself to a systems-based approach to attacking a design problem. Modular in that it's inherently, as an assembly modeler, focused on building large assemblies that can be reused across multiple projects. Generative, everything, we've got incredibly powerful generative modeling capabilities that John's going to talk about, and continuous, being able to go from a super concept design through to a detailed manufacturing model to end of life for this product. And we have a pretty large functional coverage across all of those building and infrastructure fields. We're IFC compatible. We integrate with lots of different file formats, and we've done work with some of really iconic customers on really iconic projects, including Zaha Hadid here with the Henderson project. A lot of modular builders are moving into the platform to optimize and become more efficient in their manufacturing and transforming the construction industries. And of course, another shout out to the Zaner crew, facade makers that are building some of the most complex projects in the world. So with that, I'm going to hand it over to John Cerone. If you'd like to learn more, you can check us out here. And I'm sorry, you've got.
That's great. That's all good. Thank you, obviously, TT, putting this on. It's an incredible event. I always appreciate. I'm a shorter one. I appreciate talking to kind of process, people that understand the technicians, the sort of fellow nerds in this, so I can fire hose this a bit. Right, synthesizing design and execution. Obviously, also thank you to Dassault. I mean, I think, Matt, you mentioned we were not quite 20 years ago, but we started this journey committing to a process. The foundation of SHoP was kind of understanding that there is a divide in architecture, a growing divide in architectural practice, where there's a sort of theorists, thinkers, academic thought, and then we have technicians, and we have detailing, and we have the kind of the hard stuff, the hardware. And we just foundationally, we have to do both. We have to do both. We, you know, we have our projects kind of are varied across the board in scale. We're now global, but this has always been the case where, you know, our attention towards what the thing is made of and how that material is produced, that is the common thread. It will continue to be the common thread. We're going to talk about sort of design, automation, but hardware and logistics. And there is technology involved. We're well aware of this. We are technophiles, but in pursuit of design. And honestly, we've kind of, as an industry, it's still the same game of creativity, complex design, and then how can you execute it by distilling it to a piece and a part, and how do you distill that to a piece and part. Sorry for that thing. And other industries have this. We've always looked towards other industries, the relationship of a part component to an assembly to the design of the whole. That relationship of hierarchy of structure and communication, the tool. So these are sort of like the oldie but goodie slides. I'm going to jump through quickly just because it's still foundational, and everything we do sort of keeps what we've been doing in place. The early slides, the early pavilions around how something is made, what it is, how it's made. The early and almost sort of nascent or naive thesis that you can design and manufacture capital A architecture. And when you do it, the modes of communication change, how we explain this. And we're really starting to get more formalized in this concept of a digital craft. Specificity and action around what you are designing has physical implications, has spatial implications, has interface implications. And when you move these digital products, you have to get the real-time feedback of how they're produced. What are the tolerances? And this cycle on every project is how we can execute high tolerance, high fidelity, quality, large complex design. And it is logistics. Embedded in that, we should know every piece and part that is going to go through a cutting process, a milling process, a folding process. And so collectively building tools that let us, and this has been a theme through the sessions, obviously yesterday and this morning, we're really excited about the conflation and acceleration of real-time tools. There's an opportunity, you know, I think the industry was rocked from the McKinsey report that flagged the decline of productivity in our industry. And, you know, in this presentation, the sort of journey we've been on that we're continuing on, we are really optimistic that there's an opportunity not just to sort of take derivative technology from other industries, but we have an opportunity to accelerate, to embed these things in real time. And this started with this journey 2009, where in the Barclays Center, if you want to operate with the level of detail of design and complexity of other industries, you have to use the tools of other industries. So we naturally shout out to Adam Modisette. I think they're friends of his here. I know there's some people in this audience too that were on this 3-year journey. I'm not going to do a presentation of Barclays, but for nostalgia, 3 years to design something and open it over every subway line in Brooklyn, no laydown area. It is this rapid exercise of iteration, options, old V5 footage, setting up logical systems of vertical grids, interface. Grasshopper was just coming out at this time. You sort of balance, none of this stuff is impressive anymore. This was sort of hard-coded, building templates, but accelerating, and the realization that you can take design information, create engineering templates of that, and then automate that through, in this case, scripting languages, EKL. But this idea that you've got a template for design at every move, you're going to be asked how much steel should we order, what size sheet should we use. These sort of real-time explorations, and give us a week, we'll nest that for you, order the sheet size, walking into processes of going to create water jet files. All of these things sort of happen in real time. How do you track something, throw up interfaces? This is 2010, 2011. of understanding we need to visualize the status of things, and off-site manufacturing, right? This is all an exercise in design, digital twinning, execution. So the dust settles from those 3 years, and we're actually, we have a roadmap. Everything we do now, we're going to design, we're going to create cut files. I think we're very enthusiastic with the opportunity of both designing and kind of calibrating the hardware in real time. Some of those projects stuck. We were able to execute this through kind of rapid projects where we are in real time sort of building in the design logic, understanding the systems, working with the engineers, the contractors, just coordinating it in real time through, this is 2013. We were the first adopters of the 3D experience. We were the first people on the cloud, just by the series of events. But knowing that when you're designing something, you can build in the cut files, and then the execution of these things and the collaboration with fabricators, with engineers, this off-site manufacturing approach, it happens. The sort of you remove so much friction by having the information available to you. And so we have continued to move more and more projects into the 3D Experience cloud system. So this idea that we can move through products, buildings as products, down to an individual building, down to a scope, down to a rain screen unit, down to the parts, and that powers of 10 scale. Again, it's the sort of rinse repeat, the wireframe, describing something in a wireframe, and as you work with engineers, manufacturers, we create flexible, lightweight systems and then apply the expertise, subject matter expertise on top of that, and we template that. So we can execute projects, millions of parts, with sort of it's a reappropriation of effort, but smaller teams building systems. And I think we've talked a lot about systems approach. The knock-on effect that now with cloud systems, you have access to all of this information in real time. So this idea of pulling information as opposed to pushing, automation as opposed to brute force, we can create the kind of IKEA approach to projects. And the automation of this, again, we're still, as a supply designing and construction and supply chain, there's still maturity that's happening. We're all kind of awkward, but things are happening where if you understand the machines, how people are making it, you can empathize with the physical constraints, with who's working on it, and the design can start to address some of those challenges. So visualization remains the same, but you can achieve high fidelity, sort of high tolerance design through manufactured processes. We did a lot of this work through our enclosure systems. We know that it can be applied. The wireframe approach is scaleless. It can be applied towards buildings. We've had experience in volumetric modular. We still believe that this is a process to push through. We can create more templates, not just the enclosure systems, but structural systems, mechanical systems. Again, working with subject matter experts, we can templatize the constraints. Looking at what that did to other industries, the ability then to access a distributed supply chain, that you don't necessarily have to be completely vertically integrated, that we can manage the logistics, the sort of choreography through technology platforms. So logistics, how to build the tools that can consume what we're making, the parts and pieces, of course, the execution, a lot of simulation digitally, but you have to build things physically to understand and calibrate those systems. So, and again, this is, it was a one-bedroom prototype of a market rate, New York apartment, but this constant calibration of design, are you able to achieve design through industrial processes? Scaling those things up. A small townhouse in Brooklyn we didn't design, but moving these processes at larger scale. You're sending more information out, you're receiving it from a supply chain, what are the errors, what works, how you move this through, and the things you can't unknow is that you can stack a townhouse in a day without closing a lane of construction. You know, let that guy play for a second. But you know, these checks and tests. You know, you realize at the end of this that there was, you know, we had sandwiches to celebrate. It was done at 4:30 in the afternoon. There was no dumpster on site to throw out the boxes for the sandwiches, which is, you know, you don't think about that stuff, but you have to keep kind of reminding yourselves of process and what's happening. And yes, I think we can achieve architecture. We can scale this. We develop the tools to handle more data, more information, larger logistics understanding. And in parallel, you can start to, if you're in this sort of industrialized mindset, you can start running experiments. You know, an oldie study we did with TT and collaborators around material science and additive manufacturing resurfaced, where can we look at building components, making them more solid state. And you can run these sort of quick cycles of 3D printing and bio-based materials. There's funding. I think people want to move these things out there. In the meantime, the processes, which are kind of clunky at first, get more and more refined. The throughput is faster. And this, you know, this ability to both advance how we design, how we engage makers and material science. While you're in there, you can take literally a 20-minute study to take the floor cassette, run it through an optimization tool. It literally is just another sort of workbench. I don't call them workbenches, but another app, topology optimization. And again, it's not necessarily, we would want to obviously get this run through a structural engineer, but the idea that you can start to think of solid state parts, what are more efficient uses of material. This is all available to us to understand our buildings, the components. And again, we're just kind of reaching the same capabilities that have been available in other industries. So to this, it gets us into these sort of fringe studies where we're looking at products, the ability to understand parts of a solar cart charging station, understanding how that sort of builds into a design catalog, protoform of, can it respond to environmental factors? Can we build sort of topological logic and then understand as we design it how the effects of that through a manufacturing floor. Working with TT on modular data centers, you know, similar, this idea of designing something, understanding its constituent parts, and then understanding the relationship, the subassembly of those. Again, through these sort of wiggly systems, not that we're wiggling the design all the time, but the ability to keep things flexible. We don't know how wide it needs to exactly be. NVIDIA is going to release a new thing. It's going to change the dimensions. Can we keep this live, updated? Can we share models in real time with the manufacturers, with the fabricators, so there's no loss of fidelity? We're all speaking that same language, and now we're coordinating digitally to understand design, execute prototypes. On the side, you can do sort of aesthetic performance mock-ups, this ability to move quickly so that we can start to get design and prototyping in sort of weeks as opposed to months and years. And then as those scale as systems, continuously sort of building off of those logics. Infrastructure, bridges, we opened again, all kind of developed all through digital process and modeling, understanding the parts, working with the fabricators. Yeah, you know, these things are collected. It's kind of the typology of the project. There's always opportunities to push this. We're you know, modular for a lot of different reasons. Schools, child development centers, designing products or places that make products. I mean, this is increasingly of interest and sort of in the rapid sort of understanding of design and deployment. And then I sort of, you know, how this scales. We're very excited of the past month of the progress on the Atlassian headquarters that we're working on in Sydney. Again, a project that at so many scales and complexity. It will be, I think, the tallest, I'm a couple minutes over, but I'll blast through. This is a manufactured product. It will be the tallest mass timber project. It is a series of, it's an super steel exoskeleton with super plates, concrete core, and 4 to 5 story mass timber villages in the middle. And I put this in because this isn't different than the car charging station versus the Barclays facade. This is a continuation of these processes. These are designed and manufactured products. And I say this because at this point, and this is where it's covered, and I'm sure it was covered a lot in yesterday's conversations, data. In the course of these projects, we are building tools to understand and working with solutions that understand millions of parts in real time, pieces, design as a exercise, design as a global effort, but the pieces and parts of that. And as we do these things, and this is going to be a little reductionist, but we are now, in the past year, are in this process of ingesting and understanding our data, what is in those files, or in those platforms, or in disparate platforms. And I put this in because, the obligatory sort of AI, but the reality is, with knowledge graphs, the way these are happening, I mean, I think we've seen a lot of simulations. I'm showing them as well, the visualization of how things work. The reality is, those simulations will be executed in real time. The visualizations are important, obviously, for us to engage, but we're going to be increasingly operating in a sort of if this, then that logic system of data sets, rationalization, and interconnectivity of what needs to happen. And that's going to enter in the physical world of production lines and how we operate, manufacture, build, and then manage our facilities. So I sort of this was my off ramp. There was extra crazy stuff, but we're continuously excited to have, one, participate with these incredible groups and networks and see the acceleration of these tools. So thank you.